Okay, so this is lecture 1, and we will be basically today we will be discussing some basic functions and how to plot those basic functions. Okay. So, my audio is clear, right?
Yes, sir.
Okay. So, you know that any function plotting, there are certain things has to be done, and so let us look at some simple functions which all you know. Okay. So, yesterday I talked about what are the content we are going to discuss in our course. Now, let us straight away get into the topic. So, the how to plot functions. So, let us just take a simple function x square. Okay. So, when you plot a function, so what are the things you should be worrying about? Okay. So, the domain is obviously what is the domain of the function you are looking at. So, this is basically in the minus infinity to infinity. And so, one crucial thing is you have to find out this function. So, this is your y, which is f of x is equal to x square. So, this function, so look at 3 points initially. One is at x is equal to 0. Okay. So, at x is equal to 0, what is the value of the function? So, this x square is 0. So, you mark that. Okay. So, in your answer sheets or when you later on whenever you do any kind of plotting. So, there are certain important points. So, one of the point is s is equal to 0. And second thing is at x tends to plus infinity and minus infinity. So, what happens to this function when x tends to plus infinity and minus infinity?
Sir, it tends to infinity.
Sir, it tends to infinity.
Infinity. Okay. So, plus to infinity, it goes to infinity and this infinity. Okay. So, these 3 points, important points at x is equal to 0, plus infinity and minus infinity. Okay. So, these 3 points you know the function values basically. Now, next thing is whether there is any maxima or minima for this function. Is there a maxima or minima for this function? Yes. So, where is the minima? There is a minima at x is equal to 0. So,
yes, sir.
So, so that is the second thing you have to find out, how many maxima and minima are there for the function. Okay. So, and at what point it happens. So, here it is very clear that x is equal to 0, there is a minima. So, next thing you have to think about is, okay, at x is equal to 0, what is the slope? Obviously, the slope at x, because x is equal to 0, there is a minima. So, the slope here is 0. Right? So, I think this information is more than enough, okay, to plot this function. So, you are plotting this function, and so at here the slope is 0. So, the slope is 0 here, and when x tends to infinity, function goes to infinity, and x tends to minus infinity, the function goes to infinity. Okay. So, this is the main things you have to look at. One is function values at these 3 important points, 0, plus infinity, minus infinity. Second thing is whether maxima or minima occur in the system for the function. Third thing is what is the slope at 0. Okay. So, with this knowledge, now you can get into the function e power x. Okay. So, function e power x. So, what do you think the function e power x? So, 3 points at x is equal to 0, what is the value?
1.
1. So, that important thing you mark 1. X tends to infinity, the function goes to
Infinity.
Infinity. and x tends to minus infinity, function goes to
0.
0. Okay. At x is equal to 0, what is the slope? Okay, is there a maxima or minima for this function?
No, sir.
No.
No,
No,
sir.
sir.
Then x is equal to
No,
0,
sir.
what is the slope?
1.
1.
1.
So it goes like this. Okay, so very fastly it goes to infinity because it's exponential function. So it is exponentially blowing up to infinity. Okay. So here it is slope is 1. Okay. So that is fine. So now you understood this. So now you can actually easily quickly plot e power minus x. So e power minus x will be this opposite, right? Because it's a mirror of that. So x tends to minus infinity, it goes to infinity, and x equal to 0, 1, and x tends to plus infinity, it goes to 1, 0. So it is fastly goes to 0 and goes to infinity. So fine. So now those things are known now. Now let us look at the function e power minus x square. Okay. What about this function? X equal to 0?
1.
1.
So 1.
1, and x is equal to plus infinity?
Equal to go to 0 at plus infinity.
Minus infinity?
Again 0.
And is there a maxima or minima?
Sir, maybe maximum at 1.
1.
Maximum.
0. Maximum at 0.
Maxima at 0.
Yes, sir, 0.
What is the slope
Sorry.
at x is equal to 0?
0.
0.
0. Okay. So because now I am scaling it up because 1 I will keep it here. So this is x is equal to 0, 1. So this is a Gaussian function. You know that it appears at so many places. If you are large class, okay. So this is actually the grade distribution will be like a Gaussian distribution. So or normal distribution, you can see that so many people, only very few people get S grade, and very few people actually fails, and most of the people will be around the average. So okay, we can think about how to find the average or probability distribution. Okay, all those things we'll learn later, but right now you understand that this Gaussian function, which looks like this, and so is it what is the integral of this function? E power minus x square, is it finite?
Yes, sir. I think it equal to 1 or something.
Okay, so this is an exercise for you. You have done a lot of integrations. So find out
1 or 5. Forgot.
Find out the integral 0 to infinity dx. Okay, so this is an exercise. Okay, so find. Okay, so Gaussian is clear now. Or the Gaussian function or the e power minus x square normal function is clear now. So now let us look at y is equal to sin x divided by x. Okay, y is equal to sin x divided by x. So this function, now you tell me. Okay, so x equal to 0, what is the value? X tends to plus infinity, what is the value? X tends to minus infinity, what is the value?
Sir, x tends to 0 is 1.
1.
X tends to 0 is 1.
Yes, sir.
Yes, sir.
Then
And infinity and minus infinity, it will tend to 0.
infinity and minus infinity,
will tend to 0
Tends to
because
0.
sin x is bounded.
Okay, so I just want to add is if you want to record it, you record it, okay, but after recording you see whether that video is good or not. I don't have any problem if you record it, okay. So I am anyway recording the video. If you all want to record it yourself, no issue, I don't have any objection. So you can record, no problem. So anyway, so coming to this, so some people said that sin x by x, okay, is in the value at x is equal to 0 is 1. So how did you get that? Because I know that some
So like we will
yeah.
So by applying limit, we can get it.
So limit
exact 0 we don't
limit x
Limit
tends to
x
0
tend-
sin x by x. So how did you find the
Yes.
limit?
By El Hospital rule.
By L'Hospital rule.
Taylor expansion.
Yes, series expansion we can also done.
Yeah. So what is the expansion of sin x?
It is
X minus
See, now these things you should come immediately in your mouth, okay. So what is the expansion? X minus
x cube by 3
X square.
factorial.
x cube by 3 factorial plus x raised to 5 by 5 factorial plus etc. Right?
Yes, sir.
And divided by x. So you can see that x is there everywhere, right? So
Yes.
I can
Yes, sir.
actually remove this x from the denominator and 1x I can keep it up. So when x tends to 0, you can see that this goes to 1. So that is correct. It is 1 when x tends to 0. So now when x tends to infinity and minus infinity, it goes to 0.
0, sir.
It goes to 0. Okay. So because sin x value is always between plus 1 and minus 1. So when x is very large, the denominator is going to take over the numerator. So obviously it goes to 0. But is there any maxima or minima for this function?
No,
Sir,
sir.
I infinite minimum and maximum.
Infinite maxima and
And
minimum. Okay.
minimum.
Okay. So infinite number. But when do they happen? At what points maxima or minima?
Sir, at 0 maxima happen and then
Okay, so
at
whenever sin x is having maxima or minima,
Yeah.
this function also will have maxima or minima. Is it a symmetric function with respect to the y-axis?
yes, sir.
Yes, sir.
Okay, it is a symmetric function. Okay, so what is the slope at x is equal to 0?
Sir, 0.
It is 0.
Oh, 1. Yeah, 0, sir.
0. Okay, so slope is 0 and it is a symmetric function. It damps down, okay, and goes to 0. So it is symmetric. Okay, so it's a symmetric, come like this. Okay, so maxima. Okay. So what about this integral? Is it finite or infinite?
Finite.
Finite. How do you find out the integral? See, each time the amplitude goes down, okay, because the previous thing. Okay, so you try to find out the integral of sin x by x 0 to infinity dx or minus infinity to infinity sin x by x dx. So these are exercise you do it by the next class, okay. So this is also done. So now let us look at the hyperbolic functions. Sine hyperbolic x. So what is the definition of sine hyperbolic function?
Sir,
You know what is an
It's,
hyperbolic function?
No, sir, I don't know.
so it's
No,
e to the power x minus e to the power minus x by 2.
Okay, so let me, because you know, see what is sine x, okay, So, sin x you can write it in terms of e power I theta plus e power minus I theta. Can I write? What is sin x is equal to? E power I theta minus
Subtract.
e power minus I theta.
I to I.
Okay,
I to I.
x, right? It's not theta, x divided by
2I.
2I. Okay. Suppose you substitute instead of x iy. Okay. Instead of x you substitute iy. So, what you will get? Sin iy which is equal to e power
minus y
minus y
minus y
minus e raised to power y upon minus 2y.
minus 2y. 2
I. I should be 2i.
2I. Okay. So, you can see
Okay,
that. So, where y is a real number. Okay. So, here y is a real number, here x is a real number, because in this expansion x is a real number. But you can, if you can actually substitute, if x is a purely an imaginary number, you can write like this, it will become like this. Okay. So, now I will write down the sine hyperbolic as sin hx as e power x minus e power minus x divided by 2. Okay. So, now you can see the relation between sin iy ix and sin hx. What is the relation? What is sin hx ix is equal to?
Sin x by I.
No,
Sin
what
x
is-
into I.
Oh, okay. So, I have given this one, okay, and sin hyperbolic x definition. Now, find a relation between sin, okay, sin x, and sin hx. Okay.
So
How
it
to-
is the imaginary part of sin iy.
Okay. So, you can actually find this, you can write as sin I x is equal to something into sin hx, okay, whatever. Okay. So, you like that, write that. Okay. So, the sin hyperbolic x is this. So, there is no complex thing here, okay, there is no imaginary means I, okay. So, root minus 1 is not there. So, what is the expansion of this? What is the expansion of this? Sin x expansion you knew. So, what you get when you expand this?
Sir, 1 plus x plus x to factorial, that is for e raised to power x.
Yeah. So, you know the exponential x. Exponential x is 1 plus x square by 2 factorial plus s cube by 3 factorial plus etc. E power minus x you know,
Yes.
because you will have alternate negative signs. So, if you add them and divide by 2, what will you get? Not adding, you
They are
subtract,
the odd part.
you get odd
Yeah,
terms.
terms,
So,
odd
what
terms.
is that? X plus s cube by 3 factorial plus x raised to 5 by 5 factorial plus etc.
Yes.
Now let us plot this. Because so many places these whatever the functions I am talking will appear in physics. Okay. So, that's why I am selecting certain functions which are very much important to us. Okay. So, yeah, x tends to infinity, what will be sin hyperbolic x or hyperbolic sine?
Infinity.
Unity.
Infinity. Then x tends to minus infinity,
infinity.
X is equal to 0.
X is equal to 0, it's 0.
X is
Zero.
equal to 0, 0. And slope at x is equal to 0?
So 1.
1.
So 1.
1.
Yes, sir.
So x tends to minus infinity, it is, so x is equal to 0 it is?
Minus infinity.
X is equal to 0 it is?
0.
0. X
Zero.
is equal to plus infinity it is? Infinity. X is equal to minus infinity. This one. The slope here
Yes,
it is 1. So,
So 1.
right. So, this is sine hyperbolic. So, cos hyperbolic is what you have to do is just add plus sign here. That means you will have even terms, right. So, 1 plus s square by 2 factorial plus s raised to 4 by 4 factorial plus etc. So, in that case, how does this x tends to infinity? What is it?
Sir, infinity.
X raised to minus infinity?
Infinity.
Then x is equal to 0
1.
and x is equal to, what is the slope at x is equal to 0?
So 0.
0.
So, is there any other, so any other maxima or minima for the function?
Minima at x equal to 0.
Anything
Yes.
other than that, because that already you know that slope at x is equal to 0 is 0. Slope at x is equal to 0 is 0. Yeah. So, there is no other thing, right? So, now I can easily plot this. So, this is value 1. So, is it symmetric about x axis?
Yes, sir.
So,
Yes,
that is the important
Y
thing you have to look y axis, okay. So, that is the important thing you have to look at, because when you plot, at least the symmetry is there, your figure should look like, okay. I am not saying that exactly that, okay. It should look like, because drawing by hand it may not happen exactly symmetric. So, should at least look like a symmetric, okay, when you draw it. Okay. So, now let us get into tan hyperbolic x. So, you know sine hyperbolic x and cos hyperbolic x. So, tan hyperbolic is a very important function, because it happens so many places in physics, okay, in the magnetization, Ising model and etc. Okay. So, tan hyperbolic x is sine hyperbolic x divided by cos hyperbolic x. So, this is equal to e power x plus e power minus e power minus x divided by e power x plus e power minus x. Yeah. Now, you tell me, at x is equal to 0, what is the value of
It will
tan
be-
hyperbolic? Yeah,
Sir,
0.
it will be 0. At x equals to 0, it will be 0.
0. Okay. Then
So at x equal to infinity 1.
s raised to infinity 1. Okay.
At x equal to minus infinity minus 1.
Yes, sir.
Okay, because some of you may not have understood how that has come. Whatever they said is correct. At x is equal to plus infinity it is 1, minus infinity is minus 1, and at x is equal to 0 it is 0. And what is the slope at x is equal to 0?
1.
So 1. So, if you plot this, okay, let us see how that has come. Obviously, x is equal to 0, the denominator is 1. So, there is no problem. So, in the numerator is 0. So, 0 by 1. So, 0, no issue. But x tends to infinity, So, if you just put it in this, what you get? You go, so what happens in that? How can you say the limit? Basically, you take x tends to infinity in limit. So, when x tends to infinity, e power minus x will goes to 0, right? And so, this part and this part will goes to 0, and both of, because this both actually, now what you can do is you can take e power x outside numerator and denominator. So, what you get, you can write this as e power x into 1 minus e power minus 2x divided by, this is e power x 1 plus e power minus 2x. So, this e power x cancel out, okay, with even because we have not done any limit or anything. So, this is basically equal to 1 minus e power minus 2x plus by 1 plus e power minus 2x. So, x tends to infinity, you can see that this goes to 0 and this goes to 0, 1 by 1, 1. And when you want to do x tends to minus infinity, what you should do? You take e power minus x outside. So, in that case, you would get e power 2x minus 1, e power 2x plus 1. Okay. So, e power 2x and e power minus e power 2x you cancel out. So, what you get is e power 2x when x tends to minus infinity, because you have taken e power minus x outside. So, e power minus x will cancel out, and e power 2x will goes to 0 when x tends to minus infinity. So, you get minus 1 by plus 1, you get minus 1. So, now you can plot cot hyperbolic x, so many other functions. Okay. What about x mod? How will you plot this? The modular function,
Sir?
you know, right? Yeah.
So at the positive side, mod will open with plus sign, so it will be x square.
Okay.
So it will yes sir. It will be
Almost
normally
like
like
sine
the
hyperbolic.
way it is. And in the negative side, it will become minus x square. So it will be just downside.
And is there a maxima or minima?
No, sir. Only a point of
No, sir.
inflection.
Okay.
Yes, sir.
So, what is, so at x is equal to 0, what is the value?
So 0.
0. When x tends to
0.
0 plus, what is the value of this?
So it should be positive. It will be positive.
No.
At infinity, it will be go to infinity.
X, okay, limit x tends to 0 plus. What will happen?
0. 0.
0. What about limit x tends to 0 minus
Again 0.
0? Is there a maximum or minima at x is equal to 0?
No, sir.
No. Okay. So, this is the function, right?
Yes, sir.
Now, I am plotting x cube in this. Okay. X cube. So, here it is 0. Okay. So, here the
Yes.
function should actually 0 at x is equal to 0. So, that should actually, when you plot, it should actually, so you should not plot something like this. So, it should actually comes to 0 and then go like this. So, there is no maxima or minima there. So, what about x cube? If you plot, what you
Looking
get?
like this.
Looking like this, but are they same?
Yes.
No, sir.
No, sir.
So, when you
So
plot,
more thin.
how does this? So, x equal to 0, 0, x tends to infinity, infinity, x tends to minus infinity, infinity, and slope at x is equal to 0 is
0.
0. So, all those things are conditions are same, but now I want to plot. So, how does this looks like?
Sir,
it will increase more rapidly.
So, whether this here, okay, so increase, so which one will goes to infinity first, s cube or x tends to x mod x?
X cube.
X cube.
This
cube.
S cube. So obviously this is x square graph, and this one obviously the s cube much faster goes to infinity. So, here also it goes to minus infinity much faster. But about, so whether it goes like this, so somewhere it has to cross, right?
X equal to 1.
Yes, sir. So at x is equal to 1 and minus 1, it will intersect the graph and it will go below it.
Yeah. So what happens is when x tends to 0, the s cube will be very lower value than x mod x, right? When x tends to 0,
Yes,
this
sir.
one will be, the value will be much lower than this one. So that is basically x less than 1 or mod x less than 1. Okay. So mod x less than 1, so these two values plus 1 and minus 1, you say the x cube goes to 0 much faster than x mod x. So the value of this will be lesser than this. So the graph should be below x square. At x is equal to 1, it overtake and goes. Okay. So the slope is 0, but it will go below at x raised to 1, then it actually crosses the thing and goes to infinity. Okay. So these are the things when I ask you to plot two things in the same graph, all these features should come in. Okay. So,
Sir,
yeah.
sir, can you explain the last thing which you said? Like it will cross it.
Okay, let us not worry about the x mod x. Let us take at x square and s cube. Okay. So if you plot this, obviously x square is having a minima at, okay, and slope is 0. This is x square. So now question is x cube. So infinity things you understood, right? So x cube
Yes,
goes
sir.
to faster. So this is
Yes,
x
sir.
square, and s cube will be value very higher than x square for large x. So and here anyway this side let us not worry now, because this goes to this side. S cube goes to this side. But here, so that is what I was talking about. In this area, even it is x mod x, okay, x mod x will goes like this, say, this is x mod x. So this is x mod x, this is x square. So in this area, so I will just blow it up. Suppose this is your plus 1 and this is your minus 1, okay, these two x values minus 1. So suppose x square is equal to 0.5, x is equal to 0.5. What is x square value?
So 0.25.
0.25. What is x cube value?
125.
Point
125.
0.25.
125.
125.
0.125. Okay, I am not able to hear that. Okay, so which is higher, x square or s cube?
X square.
S square. So if the values between plus 1 and minus 1, the higher power function, okay, the polynomial of higher order will be lower value than the polynomial of the lower order. Okay.
Okay, sir, got it.
So here in this area, okay, whatever may be, suppose it is x raised to n, okay, if it is x raised to n, any m value which is less than n, okay, between 0 and 1 will be above this. Understood?
Yes, sir.
Okay. Any
Yes, sir.
m which is greater than n, that will be below this. Okay. So that is the one I explained. So when I ask you to plot like this, those features should come out.
Sir,
Yeah.
sir, I have one doubt. Sir, where are hyperbolic functions actually used and why do they come in practice? I mean, we had sine and from triangles, so where exactly are hyperbolic functions used and how exactly did they come out?
So see, you can actually see this is you first you think is why you are saying sin x and cos x, you actually got it from the some angle and all those things you are putting, right. So when I am saying sin x, this x you have already in mind theta, right. So there is some angle theta, but it is actually not true. Okay, I can define a sine function for any complex number 2. Okay, so that is the next thing. I can define sin z. Okay, this is nothing to do. There is no angle here z. Okay, it's a sine function. Okay, so sin z. What is sin z? So you use the series expansion. What is that? Z minus z square by 2 factorial plus z not square, z cube by 3 factorial plus z raised to 5 by 5 factorial plus etc. So here there is no concept of angle for z, even for the sine function itself. So when you started learning about the sine, cos and all, you associated this with the angle and with a real number. Okay. So now you can actually generalize that sine function, okay, to a complex domain also. So don't think that anything we are now getting, we have learned earlier, have some restriction. We actually learned that way. So whatever you new function you come in, so you actually should have the connection. No, that is not true. Second thing is, that is what I told you. You come up with a relation between sin theta and sin h theta. Okay. So whether I can convert sin theta into sin h theta, because sin theta e power I theta minus e power minus I theta by 2i, and sin h theta is there is no I coming to the picture. So you can find a relation. So this angle, so that's what now we are actually getting into that. So don't always, so even sin z the complex. So I want to integrate sin z by z dz, where this is a complex integration. Okay. So all those things you can do, okay, but you have to know how to do the complex integration. Okay. So those things I will not be teaching this for this course. So that's what the complex integration, okay, is not part of our course, but that is still a mathematical physics course. So many places in physics it happens. So now my function is xy x cap plus y cap. Okay. So it is a vector function. I want to plot this. See this kind of, see that is what I am saying, certain things you may not find in Balakrishnan's book or any other book. Okay. So you learn it from here. So x cap plus y cap. How do you plot in a 2-dimensional? So this, when I say y is equal to f of x, because it's very important that you understand this. When I have a y is equal to f of x, this is a which dimensional plot? What is the dimensional plot? It's a 2-dimensional plot. This is which dimensional plot?
3-dimensional.
It's a 3-dimensional plot. And again, I can actually ignore now, for time being, there is no x cap and y cap. I am not taking the vector into the thing. I can just say e power x square plus e power y square. I can do this, plus or minus whatever. It's a function of x and y. So it is a 3-dimensional plot. Okay. So if you change the number of variables to more than 1, you cannot actually do the plotting on a 2-dimensional plane. So usually in that cases you actually plot it on a 2-dimension, which is basically there are different nomenclatures. So contour plot, okay, or the projection of that particular function onto a 2-dimensional plot. This kind of things you have to do. Okay. So contour plot is basically one kind of projection. So in the next class we will learn about how to do the vector functions, okay, in a 2-dimensional plane. So that's what we are going to do in next class. Any questions?
Thank you, sir.
Yeah.
Sir, what is the origin of hyperbolic functions? From where it came? I am not getting it.
Okay, so see origin, okay, I don't know the history of hyperbolic functions, but I know there are so many places it happens in physics. Okay, so that's what I said in the Ising model or magnetism. Okay, the 10 hyperbolic functions and all appearing. Okay, and the plot sec hyperbolic x, that also appear at so many places. Okay, so many places it happens. So these are functions. So somebody asked what is the origin of exponential function. Okay. So, the thing is there are if you have a variable x, you can create any number of functions, any number of series, right. So, only thing is you have to look at whether I can have a converging series, so that there is some physical quantity attached to with that. Okay. So, if you really ask what is the basic origin of this hyperbolic function, I can look at and tell you. Okay. But the important thing is these functions are very important for physics. Okay.
Okay, sir.
So, that is
Okay.
important.
Thank you, sir.
Yeah.
Sir, one thing, sir, sir, next thing, can you please do some setting for auto focusing or something, sir? It comes in focus and then goes out of focus again and again. It in between many times it went out of focus and just
You should have told me
then came.
actually. I thought I adjusted that. Okay, so okay, you actually I made a fixed focusing. Okay, so it did a auto focusing in between.
Yes, sir. Times.
Okay, so I will try to fix that. Okay.
Yes, sir.
Any other question?